Let's look at the different types of electrodes. We have inert electrodes. Whatever examples we've been using till now have been with inert electrodes, but we also have reactive electrodes. Reactive electrodes, for example, are metal electrodes like copper electrode, and reactive electrodes will participate in the electrolysis reaction, which means that the metal may decrease in size, releasing cations in the electrolyte. With inert electrodes, the electrode will not release ions in the electrolyte. But when we're talking about reactive electrodes, means that the ions can be from the metal electrode. Let's see the difference. We'll see electrolysis of aqueous copper sulfate using inert electrodes first, and then we'll see it with reactive electrodes. So in aqueous copper 2 sulfate, you have Cu2 plus, H plus, SO4 2 minus, and OH minus. These are the ions present. Ions that will migrate to the cathode are the cations, and the one that will be discharged in preference will be Cu2 plus. Remember that Cu2 plus, that copper is less reactive than hydrogen, therefore Cu2 plus is preferentially discharged. So Cu2 plus is discharged, and this is going to undergo reduction. So Cu2 plus 2 electrons giving copper. Because you have the formation of solid copper in the cathode, means that you're going to observe a reddish brown deposit on the cathode. Now at the anode, you'll have OH minus and SO4 2 minus, which are going to migrate, and the one which is discharged in preference is OH minus. Remember that SO4 2 minus is never going to get discharged, so OH minus will produce oxygen and water. So you're going to observe bubbling. Now during the electrolysis, you observe a reddish brown deposit at the cathode. Because we have a deposit, you have an increase in the mass of the cathode. At the anode, you will observe the bubbles. The bubbles are bubbles of oxygen gas, therefore the gas relights a glowing splint. And we see that here the Cu2 plus ions are being used up. So the concentration of Cu2 plus ions decreases, and the color of the copper sulfate electrolyte is because of that Cu2 plus. When the concentration of Cu2 plus drops, the color of copper sulfate fades. So we have a change in color from blue to colorless because the concentration of Cu2 plus decreases. So I've added this part. So color fades because the concentration of Cu2 plus in electrolyte decreases. So that's the labeling of the diagram for electrolysis of aqueous copper sulfate using inert carbon electrodes. Let's see what happens when we use reactive copper electrodes. So we're going to use a copper cathode and a copper anode. So here the electrolyte is going to be copper sulfate solution. So copper sulfate solution is going to produce Cu2 plus, H plus, OH minus, and SO4 2 minus. Now at the cathode, you're going to have Cu2 plus that's going to be discharged. So the copper solid is going to be discharged. You have the reddish brown deposit around the cathode. Now here, the anode, at the anode, what will happen is that because the anode is made of copper, the anode itself is going to give off Cu2 plus ions. The copper anode is actually going to dissolve in the electrolyte. So the copper anode is going to produce Cu2 plus ions, and these ions are going to go in the solution. So you have the oxidation of the anode itself because anode is reactive. So because you have the release of Cu2 plus ions in the electrolyte, the concentration of Cu2 plus in the electrolyte stays the same, because Cu2 plus is being absorbed from the electrolyte, but the anode gives off Cu2 plus in the electrolyte at the same time. So at one point, Cu2 plus is being absorbed, being removed, and at the anode, Cu2 plus is being produced. So absorbed on one side, produced on the other side, eventually the concentration of Cu2 plus stays the same. So the color of the electrolyte is going to stay the same, no change in color. So at the cathode, you have Cu2 plus and H plus that migrate, but you're going to have only Cu2 plus, which is preferentially discharged. So you have a reduction reaction over here. And also you're going to have the reddish brown deposit at the cathode. At the anode, you're going to have SO4 2- and OH- that will migrate. However, since the anode is made of copper, which is a reactive electrode, the anode dissolves and releases copper ions in solution. So you end up having Cu solid, which is from the anode, which is actually the anode. This is dissolving to give you Cu2 plus ions, which goes in the solution. So the observations here is that you'll have the reddish brown deposit. At the anode, because the anode is changing from solid to aqueous, which means that the size of the anode decreases, as you can see here. Moreover, you see the color of the electrolyte, which stays the same. There is no change in it because concentration of Cu2 plus is unchanged. So these are the observations written down.